for ALS patients. I would like to mention my faculty advisor, Dr. Geeta Rashmi. She's here. And we are from Department of Electrical Engineering. So I'll be explaining to you in detail about how the exoskeleton works and why are we designing it. So I was sorry for the picture that is so low quality. I'm inspired by a lady. She's my cousin sister. She lives in the southern part of India, and she's an expert level software developer. She is being affected by polio by her since her birth, and recently it has been detected for her arthritis, and she can't walk on her own. So I thought I should develop something which will which is very useful for mobility of such kind of people. So I and some of my friends, we went ahead and thought on the process, and we came up with this idea. This is an exoskeleton which is attached to their limbs and joints and legs, and that can move around, which will make people move around with the help of this. So we have initially used that EEG helmet. This is basically a market-ready helmet which gives out the signals, the raw data from your brain. We process that signals and we control the exoskeleton for moving immobile persons around. There are basically two types of brain-neural computer interface. One is non-invasive and one is invasive. Basically, invasive is something we operate a patient and we put electrode inside the brain to read the brain signals. And non-invasive one is the one we put externally, and it is only contacted to the scalp of the head. Difference between both of them is invasive one is the one which you put a mic inside auditorium where the speaker is speaking. Non-invasive one is the one where I take a mic across the auditorium at the end of the auditorium, and I take the signal and I process them to get good quality. We chose invasive because we chose non-invasive because invasive is a tiring process. We need to operate them. So we went ahead and we went with non-invasive. I'm sorry for that. So these are the parts where we have to cover for mobilizing a person. They are points, pressure points in the brain, which takes the waveforms which are responsible for the muscle movement. So we have to cover all the pressure points so as to get perfect waveforms. The next thing, we thought, why only for persons who cannot move? So we thought we should increase the scope. We can even go for veterinaries, accident victims, anybody who cannot move, who cannot do their works normally. So what we did is, we went ahead and we separated all the parts of the system, such as hands, limbs, legs, everything, individually communicated with the brain. So it increases the scope so that we can use for everybody. This is a statistics which shows there are about 53 million differently able people in the US. And alone in Kansas, we have 5.8 differently able people alone in Kansas who are immobilized due to some various problems. So after that, we took samples of patients who had ALS, disabilities and paralysis. We saw that people who had the EEG helmet were responding very well, and they were they were coming out of the disease, they were recovering well, 20% more than a normal paralyzed person or an ALS patient, because they know that somebody are able to respond to them. Somebody are, we know that they are telling hi to us. So it's like, yeah, they are responding. So they even increase their mental ability. Not only the physical ability, but mental ability is also increased. So let me show you a small animation which I did for working of an exoskeleton. So here is an immobilized person who is stick to a wheelchair, and we take his brain signals, and these brain signals are fed to a computer, which is basically to the back of a immobilized person. The waves are then processed, and we take the specific muscle movement, what is happening in the brain, and we give out to a controller which will control the joints. It will move the patient from one place to another as soon as he thinks. So in this scenario, we can easily know that there is no need of human intervention such as buttons, no speech, no gesture, nothing. Only that thing, they move around. It is just normal. So there is no disability even for them after this system is deployed. So with this system, we not only go for patients, but we can even use it for normal people who move, who like feel tired, who want to lift. I want to lift up this bench, but this is too heavy for me. I put this system for me, and what happens is as soon as I think, the system will give me extra strength so that I can lift up the bench. So it's like your ability increases there. So basically, it is an overall improvement where you feel like this. Okay, well, actually we do not fly. After this system is deployed, you can do your daily work as usual. You can go around, move around the lawn, pick up logs. It's all, your strength is increased there. So then we went with the training process. We took the samples of the patient and recorded the graphs. You can see that EEG when reading a textbook is very low and nominal. And we have recorded EEG when watching cartoons. You can see that the graphs go very high. People get excited, and we have used that excitement for further development because we get more frequencies, we have more values, so it's an advantage for us. Next, what we do is, this is the training process where we show the patient different types of images. I want to tell hi. Patient want to tell hi. I show this hi image, some iterations of 10, 20, 30 times. So when he wants to say hi, he will imagine the waveform which when he saw that hi image. So whenever the waveform is obtained, we see that okay, he wants to say hi, the system automatically will say hi. So it is like automatic, everything is automatic. So based on the patient's, what is the scenario, what is the patient's problem, and what is severity, we see that the training period goes with 2 months, 1 month, 3 weeks, it depends on the patient to patient. So, well, these are the images, so we show you differentiated cartoonized images and this. Well, my video did not start yet. So this is the one which shows it's like excitement, next, what is next and all. Here comes the deployment. We actually take the waveforms and we save each waveforms. If I am the patient, I save all my waveforms to that system. When I want to work out, that system will compare my waveforms with the basic ones when I am training, and it will see he want to do it. Then the system does what I want to do. So we only deploy the system to a patient when we think that his, he can handle the system, and we are always cautious that the patient does not hurt himself. So I want to conclude my project saying that with this system we can obtain remobility, and dependency is increased, and we can even get employment for about 50 million because everybody can work. There is no disability anymore, and we have quality of life and positive environment all over. Thank you.
So when you say strength increases in this suit, is it due to like more neural activation, or is it a biomechanical advantage of the suit?
No, it's not due to more biological activity. It is because we have servo motors all along the joints, which will move. Even if I want to move like this, the machine gives me a strength so that it automatically moves. I don't have to move it like this. So strength is automatically increased. And people may get doubt like, how can an immobilized person carry this exoskeleton? That is the main question which have to arrive. We solve this by a process. Exoskeleton will not be carried by a person. Exoskeleton will carry the person. It will be, the patient will be on the exoskeleton to move around.
So So potentially it could work for spinal cord injuries?
Excuse me?
So potentially it could work for spinal cord injuries?
Yes, even spinal cord, everything can be resolved.
So is your exoskeleton restricted to certain length of motion, like home flexion extension?
Yes,
or
we
your-
have to restrict it because my hand, I'm doing this. So if the extension goes back,
What about like pronation, supination, or external rotation, or are you just in the frontal?
it depends on the complexity, how we go around based on the patient. We take the degrees of freedom. If you want to move around more, we increase the degrees of freedom according to patient condition.
Well,
Thank you.
there's definitely some interest. I think this will be a great time to continue that conversation. Thank you so much. Thank you, by the way, for the courtesy of staying through all of the presentations. I very much appreciate that. I know you the speakers do as well. We have about 15 minutes, so we will see you for our next session at